Hello students and welcome to my YouTube channel. In today's video, we are going to see how to calculate Spearman's coefficient of rank correlation for repeated ranks. In an earlier video, I have already shown how to calculate Spearman's coefficient of rank correlation for non-repeated ranks. Let us start. So we have this data. Using Spearman's formula, find the rank correlation coefficient for the following data. We have marks 1, which is 40, 10, 60, 20, 40, 50. And we have marks 2, 60, 50, 50, 30, 20 and 50. Now if you will closely observe marks 1, so we have number 40 to be repeated twice. And if we look at marks 2, then we have the number 50 to be repeated thrice. Now, please note that you cannot be counting the repetition like this. So we have 50, 50, 50 and 50. So 50 is not repeated 4 times. It is repeated only 3 times. So let's start. Firstly, we will rearrange the data. So we have marks 1. We have marks 2. Then we'll be giving ranks to both. So R1 and R2. So this is 40, 10, 60, 20, 40 and 50. Here we have 60, 50, 50, 30, 20 and 50. We are going to assign ranks on the basis of descending order of the marks. So over here in marks 1 we can see that 60 is the highest. So that will be assigned as rank 1, followed by 50, which is 2. Now for the third place we have 40 repeated twice. So we have 2 times 40 means rank 3 and rank 4 will be allocated to this. So in such cases what we need to do is we need to assign the average rank. So the average is going to be 3 plus 4 upon 2, which is 3.5. So we are going to assign both the 40s rank as 3.5. So this is 3.5 and 3.5. Now we are done with rank 3 and rank 4. Now the next higher value is 20. So that will be assigned rank 5. The last is 10. That will be assigned rank 6. Moving on to marks in 2. So this is 60 highest. So that will be assigned rank 1. Followed by 350. So 1, 2 and 3. Now since there are 350s, so we need to assign them rank 2, 3 and 4. So again the same thing we are going to do is we are going to assign the average of this rank. So 2 plus 3 plus 4 divided by 3, and that is going to come as 3. So all the 50s will be assigned rank as 3. Now we are done with ranks 2, 3 and 4. So next rank is going to be 5. So that will be assigned to the next higher number, which is 30, followed by 20, which will be assigned rank 6. Once we are done with this, we will add a column for D followed by D square. So D is nothing but the difference between rank 1 and rank 2. So in the first case it will be 3.5 minus 1, which is 2.5. Then 6 minus 3, which is 3. 1 minus 3, it will be negative 2. 5 minus 5 is a 0. 3.5 minus 6 will be negative 2.5. 2 minus 3 is going to be negative 1. Now D square, you need to square the entries in D. So first we have is 2.5. So we'll be writing the square of 2.5. So let us see. So 2.5 square is 6.25. So this is 6.25. Then square of 3 will be 9. Square of negative 2 will be 4, 0. Then we have again 6.25 and 1. You need to take the sum of the D square. So we will add a column for total and we'll be adding up this. So we have 6.25 plus 9 plus 4 plus 0 plus 6.25 plus 1, which is 26.5. And let us enclose it in a table. So we are done with the first part. Now for the next part, we are going to calculate correction factor, which we will be denoting by CF. The correction factor needs to be calculated for every rank which is repeated. So in marks 1 we had 40 is to be repeated, and that was rank 3 and 4. So we have 40 repeated twice, and in marks 2 we had 50 repeated thrice. So that is 2 times and 3 times. The formula for correction factor is m cube minus m upon 12, where m is the number of repetition. So if we talk about 40, the correction factor for this is going to be 2 cube minus 2 upon 12, that is 8 minus 2, which is 6 upon 12, and that's a 0.5. While for 50, which is repeated 3 times, the correction factor will be 3 cube minus 3 upon 12, that's 27 minus 3, 24 upon 12, which is 2. So therefore the total CF is 0.5 plus 2, which is 2.5. We are now on to the last step of calculating the Spearman's rank coefficient correlation. It is denoted by capital R, and it is given by 1 minus 6 times of sigma d square plus the correction factor divided by n into n square minus 1. Now if we'll just check, we have got this in the table. So sigma d square is 26.5. Then the correction factor we just evaluated here, 2.5. We need n. N is the number of bivariate data that which we have. So we have 1, 2, 3, 4, 5, 6. So n is 6. So we'll substitute all this in the stated formula, and we will get 1 minus 6 into 26.5 plus 2.5 divided by 6 into 6 square minus 1, and that is 1 minus 6 into 26.5 plus 2.5 is 29, and in the denominator we have 6 into 35. So that's 1 minus 174, and we have 6 times 35, which is 210. So rounding off to 2 decimals, this is 0.83, and after the subtraction we are going to get 0.17. And you can state your final answer as the coefficient of rank correlation given by Spearman's formula is going to be 0.17. So that's all in this video. If you like the video, do subscribe my channel. Thank you so much.